Hi, and welcome to Pythian's Expert Insights, a series dedicated to providing expert knowledge on the bleeding edge of technology. Today we're joined by Pythian's principal consultant, Jared Still, to take a closer look at OracleNet troubleshooting for DBAs.
Welcome to OracleNet Troubleshooting for DBAs. My name is Jared Still. I'm a principal consultant at Pythian. A little bit about me. I'm a member of the Oak Table and Oracle ACE. If you know me at all, you know that I like the Perl programming language. Here's my Twitter handle and an email address you can use to contact me if you like. There's also another address at the end. A little bit about Pythian. We're a recognized leader in the remote application, or rather database administration services for Oracle applications, MySQL, and Microsoft SQL Server. And our expertise is pretty far-ranging across all of these technologies. So today, let's talk about the sqlnet topics that will be covered. We're going to consider a few common issues, maybe in a manner that you're not accustomed to doing. We're going to talk about connectivity. This is a big topic many times because anybody that's a DBA has received the call, well, I can't connect to my database, and you check the database and everything looks fine. But the person on the other end says, it can't be fine, I can't connect. So we're going to find out what some of the issues can be around that. We're going to consider troubleshooting, some available tools, maybe times you need to create your own tools, which really doesn't have to be a daunting task. This is not a configuration tutorial for sqlnet. We won't be going into any depth in configuring sqlnet other than discussing the relevant points for the tests that we'll be looking at. I'm not going to spend a lot of time introducing tools. I'm not going to be talking about syntax. Documentation can be used to look up any of those points, and you can look at this presentation later as well. What we're going to focus on is discovery. How do we find problems? Looking at issues, how do we find out what's going on behind the scenes that's causing our problem? There's lots of little brief how-to topics involved here, and we'll be talking about the tools as well. Now, oftentimes you think of something you'd like to see from a set of data to help you identify a problem, and you can't find the tool to do it. Well, maybe you can build the tool, and we'll give a couple of examples of that. So let's start with Oracle name resolution, or more than you ever wanted to know about sqlnet.ora and tnsnames.ora. And believe me, there is much more to know than what we'll be covering here. So let's consider this error, TNS 3505. Every DBA has probably seen this. TNS could not resolve the connect identifier. Well, that happens if you misspell it. But what if one is being used correctly? Well, sometimes it's worthwhile to actually read the message and consider your environment. So if you're on a Linux or a Unix variant, you can use the OR command and look up the full message for TNS 3505. Failed to resolve service name. Now pay attention to what it tells you here. Not only could it not be found in tnsnames.ora, but in any Oracle name service or a native naming service. So verify that you entered the name correctly, as we mentioned. But it also helps you to think about your environment a little bit, because there are many places you can find many of these files. There's many things that can be done to control the order they're resolved in, and we'll be considering a few of these possibilities. So let's say that you've tried this. Could not resolve the connect identifier. You know the database is there, you're using the right name, everything appears to be correct. Probably the first tool you think of to use next is not strace, but you can use strace to find some very interesting things from tnsping. So when you use strace, if you've used it at all, you know that it returns quite a bit of output. But what we're going to look at initially is for errors to be returned, and these can be identified by the equal -1 being returned, which is an error. So sqlnet trace, we'll be looking at sqlnet trace, but for right now we want to find out why we can't find that name. So in this case, I'll tell you what happened was that the tnsnames.ora file had the wrong permissions on it, and we're going to consider a way to go about finding out that. If you think of it ahead of time and you see that the permissions are wrong, it's easy to fix, but it's not a normal problem, but it can happen. The case in this case was easy to fix. It was a change mod and make it readable to the group. But how did we get to that point? So tnsping probes for optional files or locations. When you use tnsping, It's looking for all the methods by which a name can be resolved. And any files that are associated with that, it attempts to open. So we can do strace tnsping on this database, for instance, JSO3. And we're sending, in all cases here, we're sending the error output to dev null because we don't care to see it. All of the tracing output is sent to standard output. So we're looking for stat calls and open calls. Now, stat call is a probe to see if a file is there, basically. We see that in the first line here. The return code is 0, so yeah, the file is there. And it was successfully opened and returned file handle number 6. So now let's look for attempts that fail. Not just everything that is trying to open, but only those that fail. But there's still too much output. So look at the first one here. We see a -1 ENOENT, which means there's no such file or directory. This is very standard procedure for Oracle to try and open files that don't exist. What it's doing is looking for a particular file that it needs, but there's multiple locations that it may be found in. So it has a list it goes through until it finds it. So it's pretty normal to see these. Way too much output for us to make good use of. 67 more lines following these. So why don't we narrow that down a bit? Let's look for probes that succeeded, but the open failed. And this is how we'll find that permissions error. So in this case, we're using strace. We're looking for stat and open calls on tnsping again. Now look at the grep command line there. We're looking for one line following the stat. That's what A1 means. The E, minus capital E, is extended regular expressions. And we want to find the lines that begin with stat and end with a successful return. And then we're going to look for, manually, look through the output for those that failed. Oh, and look, we see the last line there, -1, and the reason is access, permissions denied. So we probably should have read access on tnsnames.ora for whoever is trying to use tnsping here, so we can see that that's the problem, and the fix was simple once we know what the problem is. What else can you learn from strace? Again, sometimes it's very worthwhile to read the documentation. So if you look at strace, for instance, the -e trace equals set, you can specify a comma-separated list of arguments. So you can look for different calls. So let's use it to find all the files that tnsping tries to use. So we use strace, -e, access, open, and stat. We're going to see every file that it tries to open. Well, maybe not quite every file. You'll notice there's a grep.ora. We're really interested in Oracle configuration files. The file reference to your strace tnsping files is included in a link at the end where you can look at this file later. But the relevant parts are on the next slide. And we'll discuss the output just a bit. And it'll show us the default locations for tnsnames. One thing you may have noticed is that when I did tnsping, the SID I was looking for is no such SID. Why do you think I might have used that? Well, the reason for using no such SID is I know that there is no such SID. So Oracle is going to exhaust every possibility trying to resolve that name and look through all of the files. So we can see here the list of files that end in .ora that tnsping attempted to use in resolving this name. The third one is kind of interesting, etc tnsnames.ora. They can all be very interesting, but this one has some special properties that we'll discuss a little later. But notice that the local file there in my home directory, .tnsnames, it attempted to open that twice, or did open it twice. I'm not sure why it does that twice. It did it with tnsnames as well. sqlnet.ora, as you may have noticed, was the first file opened. This file is often taken for granted, but you really need to be careful with it. We'll just discuss this file just a little bit here. Many people are using rack databases, and here's a good way to break a rack system. Create sqlnet.ora in Oracle Home Network Admin, and then do something like put names directory path in it, specifying, say, tnsnames and LDAP. Now, by default, rack doesn't use a sqlnet.ora file. It uses the easy connect method for intercluster connections. But what happens when you put in names directory path and use tnsnames and LDAP? Easy connect is excluded. And when you exclude it, then rack can no longer connect, and a few minutes after this is done, your nodes will go down. I've done this on my own test systems, and it took a while to troubleshoot, and now I know exactly what happens when you do that. It's not necessary to set up a names directory path most of the time. tnsnames, LDAP, and EasyConnect are default naming methods. They all work by default. Oracle looks for LDAP.ora and tnsnames.ora when the directory path is not set. But when you do set that value in sqlnet.ora, it excludes any naming method that is not explicitly mentioned in the parameter. So in the previous case, we left out one, and it was not used. And that would be EasyConnect. So EasyConnect would no longer be possible. So previously, we saw the default order of operations for searching tnsnames.ora, LDAP.ora, and we can control that order by the names directory path. Well, how do you think Oracle does this? Does it reorder the file path internally and read them in a different order? Or does it just read the files always in the same order and shuffle the values in an array? You might wonder why I would want to know this. Well, I'm just curious, and sometimes having knowledge of how things works can be very beneficial at a later time in troubleshooting issues. It's always good to know how things work. So I devised a test to determine how that works. Yeah, we can see that it changes the order of the directory path, or rather reads them in the order of the directory path. So Oracle just shuffles the order that they're read in. We can see sqlnet.ora is still first, then there's fips.ora, which is a security file, which we will not be considering today. Then it read LDAP, just as we see in the names.directory path, and then tnsnames. And as there are no configuration files for EasyConnect, we see nothing there, but it would be the last one considered. Now, tnsnames.ora is often used to override global configuration for a database. Let's say you have a development database that has a database called JSO3. And you're using tnsnames to override the global directory for that because it's a copy of a production database and you want the access to be local. But what if you change the directory path on that without considering what is being done on that server, and you set up LDAP for tnsnames? That could be a problem. When you do tnsping here to see how it's being resolved, we see that the LDAP adapter is being used to resolve this name, and it's actually pointing to what in this case would be a production database. Probably not what you want on a development database. So when you modify these parameters, you have to be very cognizant of the effects that it will have on the environment. So here's why JSO3 was not found locally, and you probably have already guessed by now what happened. When we do an strace to find out which files were considered in what order, we see sqlnet.ora was opened and then LDAP.ora. Oracle was able to resolve that name via LDAP, and it stopped looking. Regardless of what other files it might be found in, it didn't take them into consideration because it found it via LDAP. If you have databases on Windows, you're probably wondering how this applies to you. Is this order of operations the same across all platforms? Well, not exactly. Interestingly, there is a trace available for Windows that works. I have used it. You can do similar tracing on Windows. That's what you can do on Linux and other Unix-based OSs. The default order of name resolution is somewhat different. The first, by default, is tnsnames.ora in the current directory, and we'll discuss what a current directory is in a few minutes. And then Oracle Home, Network Admin, tnsnames, and LDAP, and then LDAP again. Notice that there's two different LDAP.oras, and this is the same across all platforms. There's one in LDAP admin and one in Network admin. So make sure that you're using only one of those and not both of those. And there's some more information available in that referenced file. So what is a current directory in Windows? It's not the same as it is on Linux or other Unixes. In Linux, the current directory refers to the directory that your command prompt is sitting in at the moment, or a script is in because you sent it there. But current in this context refers to the directory that an application starts in. So on Windows, different applications or different copies of the same application can use different tnsnames.ora files. They can have tnsnames.ora in the directory of the application, and that is the one they'll use. That might be useful when you're testing a new version of an application or comparing to an old version and you have to connect to different databases. Maybe the names are hard-coded into the app or they're not easily changed. Well, you could have a tnsnames.ora in the old app to point to the right location, and the same for the new one. So you got to keep in mind that it does work a little differently. Of course, if you're coming from Linux land or other Unixes and coming to Windows, you need to be aware of how Oracle Home works in Windows. It's not quite the same as it is in Linux. Oracle Home is something that is relevant to the binaries that are being used. Don't set Oracle Home in the environment because it'll break how things are working. They will not work the way that you expect. Oracle does have a support note on this. Document ID is specified there on how to set or switch Oracle Homes on Windows. You don't want to set it in the environment. It's determined at runtime. So using Oracle Home can really complicate your sqlnet configuration and your troubleshooting because the wrong or the ones you do not expect Ora files may be used rather than the ones that you want to be used. Perhaps you're familiar with the .tnsnames.ora file. Now, this is a file that any user can create on a Linux server to override or to create additional TNSNAME entries to databases. What happens if a user has been experimenting with this and has a malformed tnsnames.ora and suddenly has connectivity issues? We can see that that could be the case here. Here again, we're trying to tnsping JSO3, open sqlnet.ora, use tnsnames adapter to resolve the alias, but illegal address parameters, what's happening? You think somebody has broken your configuration. tnsping doesn't offer any clue as to what's really happened. Keep in mind, too, that on Windows, this can include the current directory. So you need to look there first if you're doing this on Windows and run into connectivity issues. And also etctnsnames.ora. We will discuss that some more later. So in this case, we'll find that the problem was actually in the .tnsnames.ora file. So we did a little strace here just to kind of get an idea of what's going on. Opened .tnsnames.ora. So it's using the user, in this case me, local.tnsnames, but it's not complete. Maybe somebody was experimenting with it. But in any case, JSO3 is not found because the entry is incomplete. Here's a little troubleshooting tip that comes to mind that you can use. If you're not aware, tnsping, or rather tnsnames, whether it's done via tnsnames.ora, LDAP, Oracle Information Directory Server, regardless, those are just shortcuts to the naming string or the connection string. So you can actually use that full string on the command line to verify that the one that you are, the connection string that you are trying to use is indeed the correct one. So you can use tnsping and use quotes, put in the connection string and close the quotes, and that'll work. Make sure there are no spaces in that connection string. Just a troubleshooting tip. So here we go. We'll talk about etctnsnames.ora. If you really want to complicate things, create an etctnsnames.ora file. It doesn't matter what you put in it. There's a little more information in the referenced file there. The fact that the file even exists can cause problems. So here's an example. Again, there are good old JS03 database. I do tnsping JSO3, works fine. Now I touch etctnsnames.ora, creating an empty file, and all of a sudden my tnsping no longer works. Well, what's going on there? Why does that happen? Of course, that can vary with whether tnsnames is set or not, but when you use etctnsnames, Oracle stops looking at other files to resolve the name. If that file is in use, it is expected to be authoritative, so no others will be considered. Something else that was found here when using Easy Connect is that tnsnames.ora is still red. Now, at this point, I really don't know why that is occurring or if it's of any significance. But using an easy connect, the tnsnames.ora file, as you can see at the bottom there, is still open, as well as the local one in my home directory. I don't appear to read anything or try to parse them because when I did this, that .tnsnames.ora file was indeed incorrect, so I didn't try to parse the contents. So let's find out what the search order defaults are and do a little experimentation here. So I'm going to set up an identical TNS name in both tnsnames.ora and LDAP. And it's not an accident that this name looks like an easy connect or hostname naming method. So we're connecting to the server Aura 11203FS JSO1. And there is the TNS names entry that I'm using. And it's just pointing to localhost. It won't actually work. But we know since there's a listener running on that one that at least the TNS ping will work. And the LDAP, as we can see, is pointing to the correct one. So let's find out what happens when we modify the names directory path. There's our command, tns ping, and our host name and service name. So without any directory path at all, the host name adapter was used to resolve the alias. EasyConnect is actually an extension of host name adapting. If I set EasyConnect, then it does use the EasyConnect adapter to resolve the alias. Names directory path set to host name, then it uses host name, as it did when nothing was set. TNS names is similar, and LDAP as well. So they all are working in the way that we would expect them to. So when we verify the search order with this command, names directory path is not set. EasyConnect hostname is not used. Use TNS names adapter to resolve the alias. Why was that? Well, we can use this to deduce what the default search order is. Even though we use an EasyConnect name, we created a TNS alias that had the exact same TNS name in our tnsnames.ora. And Oracle is using that TNS names entry to resolve this. LDAP wasn't even considered. So when we remove the tnsnames.ora entry, we see that host name is used. So what can we deduce from this? The default search order is TNS names, EasyConnect, and LDAP. And here's a table regarding TNS admin being set or not set, and whether or not TNS names exist or not exist, and some default paths. It's there for your reference. Also, there's some documents that Oracle has created regarding the search order. There's quite a bit to cover regarding this. You probably never realized how complicated it could be setting up name resolution and how complicated it can get if someone makes a mistake regarding it. A tool that is often used, and we've already used several times, is TNS ping. It's not unusual to use TNS ping to look and see if a database is up. But does TNS ping tell you if a database is up? So in this case, we do TNS ping. We're looking for a particular IP address and a service name. TNS ping says, hey, it's fine. But if I use SQL Plus to try and connect to that, we get an Aura 12514. The listener doesn't know what you're talking about. Don't know of any such service. Well, that's interesting. TNS ping worked. Well, why is that? TNS ping can tell you one thing about a database, or about the database service, rather. Is the listener up? That's all it tells you. So when we attempt to connect, as we did before, or rather just ping, we see that it seems to succeed. However, we know that it's not correct because we can't connect to it. So it doesn't tell you if the service name or SID is correct. It tells you one thing. Is the listener up? And if you look at the documentation for TNS ping, that's exactly what you'll find. It determines whether the listener for a service can be reached. It does not actually determine if the database is running. And what is the recommendation from Oracle? Use SQL Plus to attempt a connection to the database. Then you can tell if the database or the service is up. So in this case, again, we try it. We know it's there. What is the problem? Well, it was necessary to go onto the server, log onto the server, show the service names. Oh, there's the problem. Our service name includes the domain name. So I had to use .jks.com. When I added the domain name, everything was fine, and I could connect remotely to the database. You can also see the service name in listener control status. If you had just logged onto the server and then listener control status, you would see as highlighted in red at the bottom of the slide the service name that we needed. The instance is named JSO3, but we don't have access through that. We have access through the service. Probably more than once you wanted to know who is connecting to my database. Well, that's generally pretty easy to find. You can look at $session and find out who's connecting to your database. Well, what if you want to know who's connected via a local database link? Well, let's consider two databases. JSO2 is a remote database. JSO3 is a local database. On the remote database, this database link was created, JSO3 from JSO2, just to help us identify the source and the destination. So we are on JSO3, and we want to see incoming connections from a remote DB. So we connect at the remote one, do select sysdate from dual at JSO3, our database link, to establish that connection. And then on the other database, we do who DB link, excuse me. That script, by the way, is also included in the package that can be downloaded. And here we can see the information about who is connected via the database link. So we see the origin, the server, the process ID, the global transaction ID for this connection from JSO2. We see the session number and the serial number and the username that's connected. We can do the same at the other end. We can verify outgoing connections from the remote DB, so see who is connected to other databases remotely using our database link. And we can see the opposite information. Here we're on this server. That is the current one, Net01, process ID, the same kind of information. What if you want to know which database link was being used? There is no view or table that I know of that can provide that information easily without turning on auditing. Certainly there's probably one somewhere, but I've not been able to locate it. What you can do if auditing is enabled is find out the name of the database link, as in this example from the sys.aud dollar table or one of the auditing trails. And here we can see that in this case the connection was made via a database link, JSO3 from ORVM. A different one than our example, but I had auditing enabled on that database. Should you want to see how clients are connecting, you can use the $session connect info view. So in this case, we can see a number of users that are connected via TCP and some via bequeath. How can this be useful? Well, perhaps you see a user connecting via bequeath user and you're a little surprised to see that. They shouldn't be doing that. They shouldn't be on the server being able to connect via bequeath. It should be a remote connection from some other machine, so that would be useful information. There's a number of types of connections that can be made. These are just the ones that were on one of my local test databases. Some of the things that we can learn as well from this view are the authentication type, the OS users, as we've seen. The network service banner, that is what tells us whether it was TCP/IP or bequeath or something else. The client connection and the client version. So at the time of this writing, the latest version of the database is 12.102. The documented authentication type values are as appears, and this is the same as 11G. So I was curious, are there any new authentication types that have appeared that aren't documented yet? Because sometimes documentation doesn't always keep up with new versions of a product. And in this case, there happened to be another one. So it's useful to know how to query the data dictionary, because I found that for this one in 12.102, for this view, there is a new connection type called XS. It's not in the documentation, at least it wasn't when I wrote this. I should check again and see if it's appeared since then. And these are connections that are made via real application security. And this is simply found by extracting the DDL for the view on $GV session connect info. So here's a case. Actually, this will be a simulation of something that really happened. But we have a local client on a database server, and it's also connecting to a remote server. So this client process is connected both to our local database and to something remotely. Normally, you wouldn't care. But in this case, we cared because the process is consuming a lot of resources and it's really causing a performance issue on the server. We don't know what that other connection is or what it's doing. You need to find out where it's connected. Is this something we can kill? What's at the other end? Another database or what is it? Well, assuming that this is Linux, we're going to discuss how you can find the remote connection. It will vary for different platforms, how this will be done or even if it can be done. So in this case, we have process 4287. It is just killing the CPU. We look at it in this case, it's using 85% of one CPU, as we see down there under the top output. But interestingly, we look at the database information and it's been idle for 6 minutes. It's not doing anything. So you have to wonder, what on earth is it doing that's consuming so much CPU? It's not doing anything in the database. So we ran strace on the process and we find a lot of this. We see read, write, very fast. It'll scroll by the screen faster than you can read it. And all of it was to the same file descriptor, in this case number 9. So let's find out what file descriptor number 9 is. In this case, it is a network socket. And we can see the socket ID there found by looking at the proc file system. So let's find out what that remote connection is. So I use head -1 here on procnet TCP. That is simply to get the headings for the data. And then I look for that socket ID in grep procnet TCP. What do we find? Notice under remote address in red, we have in hex the TCP address and the port that it is connecting to. So now let's decode that. For our hex remote address, we can decode each byte and find out that it's connecting to 192.168.1.31. Oh, and look what O5F1 becomes is 1521. That's a very recognizable port. That's the default Oracle port for the listener. So at this point, we know that it's connecting to another database, and we can find out what's going on. Over there, if this is a process that needs to be killed or something broke, this was just a test scenario. In the real scenario, what it turned out to be was a malfunctioning remote switch, a managed switch, to which a printer was connected. And printing had been done to this, and it was simply communicating very rapidly back and forth, nothing at all, consuming a CPU, an entire CPU doing it. The fix in this case, the client replaced that managed switch and the problem went away. Well, let's talk about tracing sqlnet. First of all, if you've ever really wanted to know under the covers more about how sqlnet works, here's a document available on Oracle support that you'll probably want to read. That's the document ID, and actually it's a PDF file attached to that. It will tell you how sqlnet works and how to interpret the lowest level of trace files should you have some need to do that. We won't go that much in depth today. We'll be covering some highlights. Set up client server-side sqlnet tracing, a meaning of some of the trace info, and we'll look at some tools that can help to interpret the trace data, because trace data for sqlnet is very verbose. There's a lot of it, and it's not always very obvious what it means. And we'll set up dynamic server-side tracing, and we'll look at why we would want to do that, and maybe a way of tracing sqlnet that you weren't aware of. So let's look first at the sqlnet trace parameters. So the recommendation from the documentation is to set this off. So to disable advanced diagnostic repository for sqlnet tracing. But however, I have it set on, and there's a reason for that. It has to do with the timestamps, and we'll cover that a little more in detail later. Even if you don't use ADR, in this case, it will still create in the ADR location a file with just header information in it. Not sure why it does that, but it does. It's really of little value in our tracing efforts. Here are just some parameters I've set up. The ones that are important are trace level support level, the trace level client is set to support, which is the same as 16. We've also set unique client on. What that means is that each process on the server side, or the client side in this case, will get its own trace file. And we've turned on timestamp. We really need timestamp to see the time between events in the trace file. So we have set it on, and we'll explain a little later why we have set ADR on, contrary to what the documentation says we should do. And those parameters are the same as previous. So here's that header file I mentioned. Even if diag ADR enable set off, we see that it writes a file to not only trace the old trace directory, but also the ADR directory. So we see a file in JSO3 trace, which is just header information. Really don't know why that's created. So that was client side. Let's consider server side as well. Diag ADR enabled equals off. The following parameters are set as previous, just different values for the locations. So assuming that we've created a trace file to look at, it's a good time now to introduce the Trace Assist tool. This is a tool that you may or may not be familiar with. Among its other capabilities, it can parse sqlnet trace files. So in this case, we have an ORA 12514. And although you can also see that in the listener.log, we can see a little more detailed information here using Trace Assist. Now, using these particular parameters, we can see that received a packet, the timestamp. Oh, look at the timestamp. That should probably say 2014, so there's a bit missing there. We can see that the service name was junk, so obviously it's failing because we specified a particular server, and we're trying to connect and it's not there. We can see that the error code returned. So now let's talk a little bit about the server-side tracing issue. When you turn on server-side tracing, by default, all connections will be traced. Current connections will have tracing enabled. Long-running connections will continue to trace. So the tracing does not stop until the client disconnects. This can be a problem. If you have a very busy system with a lot of connections, it can start to fill up the disk. You have to be very vigilant to keep cleaned up after that if you enable server-side tracing to find an issue, because it fills up very rapidly. So one solution, provided you have a late enough version of Oracle, is to use dynamic Oracle Net Server Tracing. And it's documented in that support note. And there are some earlier versions of 11G that may be able to patch to use this. And why would you want to use that? Because when you do use that, instead of turning on server-side tracing for all connections, you simply target the ones that you need to look at. So we need to leave these in sqlnet.ora for this process, and we'll have some details shortly. So let's put all these things together. Here's another real-life problem. A database was moved from one version of HPUX to a later version of HPUX, and suddenly there is a performance problem. The SQL elapsed time greatly increased, but only for some clients. This particular database had both Linux clients and Windows clients. The Linux clients work fine. Running from Windows, however, the queries that used to take maybe half a second now were taking nearly a minute. And here's what the problem turned out to be, and then we'll look at how we came to this conclusion. So Windows TCP implementation is not the same as on a Linux system. The TCP on Windows does not have an out-of-band break. So the setting break pull skip is used in sqlnet.ora as a workaround. Now by default, this is 4. And what this means is that On Windows clients, for every 4th packet set, the Oracle server is going to ask the client, are you still there? And this was taking a very long time. If you increase it to a 100 or some other value, it can reduce the amount of time in total that's spent, but that's really kind of a workaround, because what the break, out-of-bound break is used for instance, is capturing your Control-C should you try to stop the query. So imagine if you increase this value to 10,000. You have to wait every 10,000 packets before Oracle even looks to see if you've hit Control-C. In this case, the real fix was something at the OS level, run KC2 high-res timeout enable equals 1. The high-res timer was not by default enabled, which is what caused the problem that we're going to look at. So here's the trace procedure. Start the program, get the process ID, enable PID, or enable the trace, and then parse the trace output. So we need to get the PID for the process, in this case 3240, set OR debug 3240, and here's the line that we're interested in. Dump sqlnet server trace 16. And then we use the trace file name command to find the actual name of the trace file. So of course now we want to see, once we have our trace, just how long Oracle is spending on the operations in sqlnet. But it was kind of a mixed blessing here with this particular trace file. I mean, we can see our information, but we don't know how long it took. Because if you look at the timestamps, you'll see that the timestamps don't include fractional seconds. What they do have is the date, the time, and then what appears to be some kind of a sequence number. And this was without using ADR. This was using the local trace directory. So if we look at the trace files, we can see that that's still the case there. I thought it might be a problem with Trace Assistant, but that wasn't the case at all. Simply the information in the trace file was wrong. It's missing a fractional second. So this information really didn't help us very much. So working with this a little further, we re-enabled ADR, rerun the trace, and find there's still a problem with the date stamps, but at least it's better because we have fractional seconds. Now if you look at the date stamp, or rather the timestamp, you'll see that what's missing is V2 in the 2014. And again, wondering, is this trace assist or is this the actual data? We see that it is a problem with Trace Assistant, not parsing the date correctly. So the data is correct. We can still use it. We have to do a couple of workarounds to actually see what we want to see from it exactly. Can't get the full year. I wanted the timestamp in there complete. So one way to do that was to use a script that is a bit of a hack, and it's included in the zip file that we'll reference later. This simply adds the 2 to the date stamps. But what we can see here is that we do trace assist, pipe it through that script, and we see, wow, between each packet, there's a second, 1 second, where Oracle is asking the client, are you there? So that adds up pretty fast. Perhaps a little more elegant solution was to just craft our own tool. And to do this, it required a little investigative work. The following notes, as shown here, were used to get a better idea of the sqlnet packet structure, and then just read the trace file ourselves and get the information we want. We added some debugging output so we can see what's going on and get the time between packets. And there we can see our delta times. We can see the correct date stamps. We see the fractional seconds. We can see what was being done, the packet dump. And it's 1 second. Again, it was consistently just below or just above 1 second in time. So in that case, the problem was that high-res timer on HPUX, where they should have taken a few milliseconds, they were taking 5 seconds, hence ballooning our half-a-second query out to nearly a minute. But these are some of the tools that you can use to find those sorts of problems. Here's another real-life case. So what happened here was developers had a logging system in an Oracle database, logging data to an XML database using log data. And as long as the server was local, everything seemed to be fine. But then the server was moved to another data center, and suddenly their queries took a very long time. So they started doing some troubleshooting and used Wireshark and found that there was a lot of packets going back and forth between the local client and the remote server that didn't seem to be of much use. Well, DBAs probably don't have access to Wireshark. You might, but even then you might need somebody to help you interpret it. At this point, I was asked to find out what was going on. And I thought, well, I'd like to see what sqlnet's really doing. You know, what's being sent to the database? What's going back and forth here? Something that's similar to what's in Wireshark, but maybe a little more oriented towards a database administrator. So I looked at ora.us.msg. Perhaps you've looked at this file before. If you start looking at the 10,000 range, you'll see these are events that can be set in Oracle. And I came across 10079. That looked like it would be just the ticket to find out what's happening here. So you can set that event with different levels, showing different types of data being sent, sources and destinations. To make use of this, I found it was necessary to combine the 1079 with the 1046 trace. I found trying to set 1079 via alter session set events did not work. And it didn't work by itself used with ora debug. So what was necessary to do was to enable 1079 and then start 1046 tracing. And then I could get the sqlnet output. But there's a problem. This particular problem cannot be tested with SQL+. You won't see the issue at all because it doesn't have any prefetch ability, which turns out to be something key in diagnosing and troubleshooting this issue. What you can test with is SQL Developer. So I used SQL Developer 4.03, started it up, got the information I need for the PIDs, set ora debug, and then enabled tracing on it. So in a nutshell, here's what we found. We find this line, more data to client, occurring 47 times in a short trace. Many small packets. We also saw lots of packets called overflow packets. And using a 12C thin client, we found the same thing, 47 of those packets. However, we switched to using an Oracle 12C client and used the connection via the thick client in SQL Developer and found that either with or without prefetch configured, that those went away. We no longer had those same types of waits going on. And it was much faster. So getting to this point required quite a bit of effort and quite a bit of coordination with Oracle support via an SR. So we did find someone who said, you know, we usually solve those problems by using the Oracle thick client, which is a great information to have. But of course, we didn't really know exactly what the problem was yet. We can see the more data from client that's shown via the 1046 trace. And we helped to identify it with that 1079 trace. And as I mentioned, overflow packets, which there were quite a few of, didn't even appear at all in that 12C thick client. So we can see whatever the problem was in SQLnet, it has been corrected with that thick client in 12C. And here we can just see some of the metrics. We can see the number of overflow packets that were sent and the size of them. This actually took a period of months to get resolved to try and track down what this problem was. It's been documented in a couple of places. If you're familiar with the Oracle L list, it's documented there. There's a test case included with the zip file for this presentation. There was a bug created initially on Oracle support. Now it's classified as not a bug, probably because it's an old version of Oracle and nobody's interested in fixing it, and it works in 12C. Simply using the Oracle 12C OCI client will correct this issue. So how else can you determine if a host is responding? Maybe you want to ping a client, but ping is blocked. It's not unusual for ICMP packets to be blocked. Well, how about using one of these tools? For instance, Oracle trace route, TRC route, a little different than the Unix one. It's kind of like a TNS ping, gives you a little more information about how a name was resolved and how it got to that resolution. What if you would like to use ping my ping is blocked. Well, there are alternatives. For instance, this is the contents of a very short Perl script that can be used to test ping using TCP/IP. And that is the entire contents of the script, and using that, I could see that Elvis is indeed alive. One final tip, ORA 12.154. I ran into this some years ago. It's documented in this old blog, as you can see, that's from 2008. Special characters can be very useful in a password. However, in Oracle passwords, it'd be better if you never, ever used the @ symbol. It can be done, but it's very difficult to quote it correctly. It can cause all kinds of problems in troubleshooting, as you can well imagine, until you realize that there's an @ symbol in that. I won't belabor you with the details here. You can read about it there, but suffice it to say, that is a good character to exclude from your Oracle passwords. So to summarize, it's really better to know how to find answers than it is to rely upon the answers you already know. If you know how something can be resolved, that's great, but having a good understanding of how the systems work and a good troubleshooting technique and the tools to use can go a long way to helping you resolve problems that you've never seen before. And don't count on the knowledge you gain on one platform being directly transferable to another. Think about how Windows works with sqlnet name resolution or tnsnames resolution as opposed to Linux and other Unix versions. They're similar but not the same. And finally, you can use this URL or this QR code to download the presentation. Thank you very much for attending.
Thank you for joining us today and watching Pythian's Expert Insights. Remember, you can connect with Jared using the information provided here, and if you want to discover more about our expertise in Oracle, visit the URL provided at the bottom of the page, or you can email us at info@pythian.com. We hope you enjoyed this presentation, and thanks for listening.